Now let's move on to question 8. Here we are given the position vectors for A, B, C, and D as you can see. And we need to show for part A that AB is equal to 2CD. So this is very simple. We just need to first find the length of AB, which we will do using our formula. But first we need to find what AB is. So that is also very simple. Now AB is OB minus OA. So that is 4 minus 1, 1 minus 2, 1, 5. So that should be 2 minus 2 and minus 4. Now we will put this into the square root. So according to our formula, it should be 4 plus square root of minus 2, square of minus 2 is also 4, and square of 4 is 16. So 4 plus 4 plus 16 gives us root 24. That is our length of AB. Now for CD, we will do the same. First we will find what it is. CD is OD minus OC. So OD is 3, 2, 3, and OC is 1, 1, 2. And that should be 2, 1, 1. Okay, now we will find the length of CD. That should be root of 4 plus 1 plus 1, which is root 6. Now, to show AB is equal to 2CD, we need to play around with this number. So, root of 24, what is 24? 24 could also be written as 4 times 6. And the root of 4 is 2, so we can bring that out and we get 2 root 6. So, as you can see, AB is 2 root 6 and CD is root 6. So that is shown that AB is equal to 2CD because CD is root 6. So this is shown here. Now in part B, we need to find the angle between the directions of AB and CD. So for this, we're going to use our product rule, which is the dot product of AB multiplied by the dot product of CD equal to the magnitude of AB multiplied by the magnitude of CD and cos theta. So we found this earlier. For AB, it is 2 minus 2 and 4. And then for CD, we found it to be 2, 1, 1. And we also found the magnitudes of AB and CD earlier. So this is root 24 times root 6 times cos theta. Now 2 times 2 is 4. Minus 2 times 1 is just minus 2. And this was minus 4 times 1 is just minus 4. And instead of root 24, we can write 2 root 6 multiplied by root 6 cos theta. So 4 minus 2 minus 4 is minus 2. And root 6 multiplied by root 6 cancels the root. So we're left with just 2 times 6, which is 12 cos theta. So minus 2 over 12 is equal to cos theta. And we can say that cos theta is equal to minus 1 over 6. And theta is cos inverse of minus 1 over 6. And in degrees, if we put that in the calculator, that is 99.6 degrees, or radians, however you'd like to find it. And that is it for question 8. Now for part C, we have to show that the line through A and B does not intersect the line through C and D. So first, we're going to have to find the lines for A and B and through C and D. So first, let's see how the equation of a line looks. So it will be equal to, let's just say A. It's first equal to any point on the line and the D for direction. Now it will be the direction of AB because the line is passing through AB multiplied by a constant, let's call it T. So this is how usually a line equation looks. Now let's try and find the line equation for AB first. So for that, we're going to take, for A means any point. So we can take either A or B. So point A was given to us as 2, 1, 5. And then the direction of AB we still have from part A. And we found that to be 2, minus 2 and 4. And then our constant we can take as any letter. I will take T over here. Now let's try and find the line equation for CD. So for CD, again, we can take any point in the line. So point C or D, I will take point C here, and that was given to us as 1, 1, 2. And the direction we also have still from part A, and it was given, we found it to be 2, 1, 1. Okay, and the constant I will choose to here call it S. Now we have to show that these lines do not intersect, and we know that whenever we've been told to show if something intersects or if it doesn't intersect, we try and to find these equations and solve them simultaneously. Now first we're going to assume that they do intersect, and so we have to equate both of these line equations to each other. So for that we will have 2, 1, 5 plus t 2 minus 2 and 4 equals to 1, 1, 2 plus s 2, 1, 1. Okay. Now we're going to expand and make 3 equations. So our first one, if we expand, would be 2 plus 2t is equal to 1 plus 2s. The second one would be 1 minus 2t is equal to 1 plus s. And the third one would be 5 plus 4t is equal to 2 plus s. So this is my first, second, and third equation. Now using these two equations, we can find the values of s and t, and then we can check in the third equation. So let's do that. First, if we look at the second equation, these ones will cancel and s will equal to minus 2t. So now we can use this and replace s with minus 2t in our first equation to get a value for t. So 2 plus 2t is equal to 1 plus 2 times minus 2t. And if we solve this, we will get 1 minus 4t, and that will give us 6t is equal to 2 minus 1, which is 1 minus 2, which is minus 1. So t is equal to minus 1 over 6. And if we replace that here, we can see that s will be 1 over 3. Now we need to check if we get these values for s and t in the third equation. So now that we have values for s and t, we're going to substitute them into the equation and see if that's true. So on the right hand side, we have 5 plus 4t. So instead of t, we will write minus 1 over 6. And that comes out to be 5 wholes 2 over 3. And, this was minus. And on the left hand side, we had 2 plus s, and s was 1 over 3. So we will get 2 wholes 1 over 3. Now, as you can see, we did not get the same answer for the right and left hand side of the equation. So the left hand side and the right hand side do not equal. So we can conclude that line AB and line CD do not meet. So with such a question, I hope you get the main idea that first we have to find line equations for both AB and CD, and then using them, we have to first assume that they intersect, and then we equal them to each other and make 3 different equations. And using the help of 2 equations, we find 2 unknown values, our constants s and t, and then we use those in the third equation to check whether the lines meet or not. And as you can see, if we get a different value, that indicates that they do not intersect. So I hope you understood that.